Good morning, everyone. Welcome to the AC400 sessions. My name is Daniel Soto, and I will be with you during this session, guys. So, feel free to ask any question that you have. There is a support team here in the chat that are going to help us answering those specific questions that you have. All right, so let's start with the content of this session. So, the name of this course is Designing and Implementing a Microsoft DevOps Solutions. So basically, we are going to cover the main aspects that you should have if you want to take this certification. So first of all, I would like to introduce myself. My name is Daniel Soto. I am a full stack web developer with a data science approach and a DevOps mindset. I started my career developing websites with HTML, CSS, JavaScript. Then I moved to the backend development with Python. And then I started to work with machine learning models. And from the last 3 years, I started to certify myself in order to provide some training in some Azure certifications, such as the AC204, AC400, EP100, A102, among others. So on the next 5 days, guys, I will give you the basics you should have in order to take the AC400. And once you pass the AC400, you will earn the following badge, the DevOps Engineer Expert. I hope this is going to be informative for you guys, and thank you so much for joining us. All right, so let's start with our first presentation for today. Give me a second while I'm opening that presentation. And first, we are going to start talking about what is DevOps. So it's a term that we'll be hearing a lot for the last, I don't know, 5 years from now. So just what is DevOps? So what is the role? What are the technologies that involved, and so on. So first of all, what is DevOps, guys? DevOps is the union of two words, development and operations. If we take a look to this definition, it's going to be like is the union of people, process, and products to enable continuous delivery of value to end users. Let me try to explain this in my own words, guys. We want to speed up the process when we want to deliver software. Remember this, we want to speed up the process when delivering software. And this will be split into multiple cycles, and on each cycle, we want to deliver something valuable to our users. Normally, or how these cycles are going to be working. Normally, in the traditional way, we used to sit down with the customer, take a look to the requirements, create an extensive list, an extensive documents with all the requirements and all the needs my project should have. And once we identify all the requirements, we used to sit down and at that moment, just write it to code. Normally, this process take about 6 to 1 year, even in some projects, more than a year. And just at the end, the customer is going to see the real value of the product. So we are breaking up with this traditional way. So instead of sitting down, instead of creating large volumes of documents and requirements and so on, so what we are going to do is that we are going to separate into small chunks. Okay? So all the requirements are going to be split into multiple or into small pieces, and we are going to be working on each piece every period. Normally, this period is going to be referred to as a sprint. And each sprint is going to be validated almost 2 to 3 weeks. And at the end of this sprint, we are going to deliver the product or the result of the sprint to our customer. In this case, this architecture will be more flexible because if there is a change, we can react faster than if we follow the traditional way. So remember, so instead of having a large volumes of documentation and requirements, so we are going to be working on the small steps that we are going to be called as a sprints. And you might be wondering, okay, but that is DevOps? No, guys. So DevOps is going to have multiple techniques. Remember that what DevOps is that we want to speed up the process of delivering software. And okay, so how we can speed up the process? By applying multiple techniques. Techniques such as agile methodologies, automation, pipelines, version control systems. So there is a bunch of techniques that are going to be part of the DevOps journey. So on this entire course, we are going to see the different techniques that can be applied and the different tools provided by Microsoft Azure that lets me apply these specific techniques. Remember that if you have any question, feel free to post it into the chat. And at the end of each session, you will have some labs where you will be able to apply some of the knowledge that you're going to have after this training. Okay, so let's continue talking about the DevOps journey. First of all, remember that we want to have a continuous iteration, So we want to deliver software to our users. So what are the different techniques? For example, continuous integration. What is continuous integration? So in continuous integration, we are looking for a mechanism that allow me to centralize all the code my developers are working on, and that's it, guys. So how we can achieve this? By using version control systems such as Git, GitHub, Bitbucket. So remember that we are going to be working with multiple developers, each developer with its own feature, and I'm looking for a mechanism that allow me to centralize this code. But not only that, normally when you deliver an application, we used to compile it. We want to create a Docker image, or we want to create a zip file. Maybe we also want to execute unit tests. So again, how we can automate this process that is going to receive the code, that is going to execute the unit test, that is going to compile the application, and at the end of this process, I want to have a product that can be deployed. Let's say, for example, an application, a Docker image. So all of this can be done by a process known as continuous integration. And for this, we need to design something known as a pipeline. So the pipeline, guys, is going to be a process. And that process can be executed by multiple ways. But one of the most common ways this pipeline will be executed is that every time a change is pushed to that specific repo. So remember, in that case, imagine that you have multiple developers working on their own machines, and every time each developer pushes something, we want to immediately perform some tests. So at the moment that we detect a change, maybe in our main branch in the version control system, we can trigger that entire process. Just pull the code, compile the code, execute or create a Docker image, perform the unit test, and only then, after that, I will have a product that can be deployed. Okay, then let's move into the next term, continuous delivery. So in continuous delivery, practically is that once we finish or once we exit from the continuous integration phase, I want to deploy that something. So what are the requirements, or what should I consider here? A, where is the infrastructure where this product is going to be deployed? Maybe a virtual machine, maybe an app service, maybe a Kubernetes. So you should consider the environment where the application will be deployed. What else? Other requirements such as maybe you are not going to go directly to production. You should consider at least two environments, an environment that will let you test the application and another environment that will let you, exactly what, once you have tested your application, you can automate the process that will let you decide such as, hey, okay, I already tested, now let's go to production. So again, so here we are deploying the application that was already created in the previous step. But normally you should consider more than a single environment. Other thing that you should consider here is that you can automate the process of creating the infrastructure that is required. Let's say that in your testing environment, you want to test it maybe with a Docker container with an Azure Container Instance or with an app service. So again, you should consider the code that is going to create those specific resources. And other thing that can be considered is that once you exit from this stage, you can delete the infrastructure or you can stop the infrastructure that is no longer required anymore. At the end, it's up to you. Other thing that is very important to mention regarding the DevOps journey, guys, is that there is no a standard. There is no a standard such as this is DevOps, this is not. At the end, it's just a framework, guys. It's just a set of tools, a set of techniques, which main purpose is to agile, is to speed up the process when we are delivering software. Okay? What other techniques can be applied here? For example, a version control systems. So how we can manage or how we can centralize or have multiple versions of the code of the application, and then also let me roll back to previous version my code had, right? Normally, you are going to have multiple branches. Each branch is going to have its own feature, but very important is at least we will have the main branch. The main branch that is going to have just the production code, okay? And we can perform different operations here. We can merge, we can rebase, we can check out. There are multiple operations that can be executed in my version control systems. What else? Other technique that is part of the DevOps journey, Agile, lean methodologies. So this is going to impact in the way that we are going to plan our projects. As I mentioned before, instead of working on large volumes of documents and requirements, start working on a small piece of your application. And this piece should be delivered or should be completed in a period that is not going to last more than 3 or 4 weeks. I don't think so. Normally, it is between 2 or 3 weeks that sprint is going to happen. What else? I can also manage the different activities my team is going to be working with, such as if we have a to-do list in progress, ready to code, or in progress, it has a bug, or it has completed. Other benefit of having this type of plan is that I will be able to measure the performance of my team, or I will be able to monitor the time each team is having to work in a progress a feature, or is working on a on debugs, or it is working or the time that is taking my team to complete a specific set of tasks. Other thing is that when we are integrating this task within the pipelines, I can also query these items. And this, I mean, I remember at the end, I want to automate this. So I can query those items. And at the time that I'm querying those items, I will be able to decide if I want to continue or not. Let me give you an example of this. Imagine that you have a bug there, such as, I don't know, the database is not having a connection established with my web application, something like that. It is a bug in the work item. So you have a developer, the developer makes a change to the repo, so the entire pipeline will be triggered. So we are compiling the application, we execute the unit test, we create the application, and then we are passing to the testing environment. So my application is being tested. Guess what? In that moment, you query from your work items, okay, and you realize that there is a bug there. There is a bug or hasn't been passed from one status to another. It doesn't make sense to continue taking this application to production if you already detect that there is a bug. Actually, you are going to work in a lab related to this specific topic. What else? Very important, monitoring and logging. There is another like another idea here, which there is some people that wants to separate DevOps with other role, which is known as site reliable engineer. With a site reliable engineer, it can be seen as a role or it can be seen as another topic within the DevOps. What does this mean? Is that we want to make sure that our environments are up and running and that are available. My application should be, it has to be available, up and running, and I need to design a mechanism that allow me to identify if the service is running or not. In the case that the service is not running, or in the case my infrastructure it is not running, I need to define a mechanism or I need to design a strategy that allow me to recover the status of those environments. So here it can apply having application insights, Grafana for Kubernetes. What else? Having systems that allow me to install a set of softwares in my infrastructure. But again, I want to automate that. For example, I can consider a Docker image, or I can consider an R template, an Ansible playbook. So remember, what is this? I want to make sure that my services, that my infrastructure is up and running, and I want to continuously monitor this. Remember, guys, I cannot improve something that I cannot measure. What else? Um, um, you can consider also having a cloud services. Maybe for the most this is most related for having a scale infrastructure that can be upgraded, that can be downsized based on the necessities, based on your needs, based on the requirements your application has. In this case, you are not going to use more than your application needs. What else? Other techniques that is part of the DevOps journey. Infrastructure as code. So if we want to automate this, if we want to automate having environments for production, for testing, for Q&A, hey, I need to design a mechanism that allow me to recreate this entire environments. And these environments should be the same across the different stages. Does it make sense that in testing, that in test you have an environment A, let's say, that in production you will have environment B? You have to make sure that at least your environment is going to be the same. So how we can guarantee this? By using infrastructure as code, such as Terraform, ARM templates, or you can configure this by using Ansible playbooks. At the end is that we want to automate everything. What else? Other thing that is part of the DevOps journey is to separate my monolithic applications into microservices. What a monolithic application is? A monolithic application is where all of the services are going to be executed in a single application. So you have maybe your login view, your blog view, your portal, your admin, all of this running in a big piece of code. So having this approach, guys, is going to have some disadvantages at the moment that we want to update something. Because if you want to update, if you want, let's say that in your administrator module, you want to add a new feature, let's say. Once you added that new feature, the entire application will be updated. Does it make sense? So if we separate this into small pieces, that we are going to call it microservices, it's going to be easier to update a specific microservice. So instead of updating my entire application, I will only update the module that is needed. All right. What else? Actually, one of the most common approaches to pass from a monolithic application to microservices are containers. So containers are the next evolution in virtualization. I will also say that is now is the current evolution in virtualization. So remember, we want to separate each module into each microservice, and actually having a container is going to makes easier having a microservices architecture. Okay, so now what we have covered, the different techniques from a big perspective, it is very important to mention that DevOps made her at first. So passing from a traditional way to design applications, passing to having a monolithic application to a microservices, and working with large members, having version control systems, automate everything might be hurt, may hurt at first. So be patient, guys. It's not easy to just pass from one approach to apply all of these techniques that we have just discussed. It might be difficult at the beginning, but definitely the benefit is going to be very, very valuable. Actually, other thing that is very challenging when we are going to pass or when we want to apply a DevOps mindset in our teams is the members. So the staff, the people that we are going to be working with, because maybe not all of the members are going to be fluent working with Docker or containers. Not all the members are going to be um, related with version control systems or with automation. This is when the DevOps comes into play, guys. So a DevOps is a person in the middle, a person that has a developer mindset, but also it also has an operation mindset. He already knows the process of creating and developing an application, but this person also is also involved with all the infrastructure that is required, such as when to place a load balancer, when to place a virtual network, how to address the CIDRs of these virtual networks, how to route the traffic at the global perspective. So this is something that you should consider. What is the availability of the staff? So other thing to overcome the challenges, you should create a team that is focused on the transformation. Definitely, we want to be more flexible to the changes that are presented, well respected in their subject areas, such as, hey, I don't know, this guy is very fluent working with Kubernetes. This other guy is very fluent working with Git. This other guy is very fluent with working with infrastructure as code. Because in all of these teams, we should have a very good communication. The communication is one of the most important aspects in a DevOps teams. So a transformation project can conflict with ongoing business needs. So again, what are the goals about this? So we need to specify or we need to define a strategy that allows us to optimize all of the process, such as, hey, I want to reduce the time that we are spending on fixing bugs. That is one of the main reasons that we want to measure the different activities my teams are working on. Reduce the time spent on unplanned work. So again, I need to define a strategy that allows me to identify these activities. Or you reduce the out of hours work required by staff to not more than 10% of total working time. Or remove all direct patching of our production system. So again, remember, we cannot improve something that we cannot measure. So based on this, we should specify a strategy that allow me to measure this. This can be considered as key performance indicators. So with the key performance indicators, we will be able to evaluate between one stage or between one sprint and another to see if we definitely are having, if we are definitely are optimizing our process. One of the key aims of the DevOps is to provide greater customer value. So outcomes should have a customer value focus. What else? So measurable goals should have timelines that are challenging yet achievable, and timelines should be a constant series of short-term goals, each clear and measurable. Remember, so we will have sprints. On each sprint, we will have a list of activities, and the main idea is that at the end of each sprint, we are going to evaluate which activities was completed, which activities couldn't be completed, okay, and measure the time that took us working on those specific activities. So with this, we will have a more organizational team, and so we will be able to get feedback from our internal team as well as from the customer, and we are going to be more flexible reacting to those specific changes. Now, when we're working with this kind of projects, you will find two types of projects, normally, two types of projects. What are these projects? Greenfield and brownfield projects. So let me start with the brownfield project. So in a brownfield project is basically you already have a base, you already have a code, you are going to start from having an existing project, and from that existing project, you want to apply the DevOps techniques, such as maybe the project is not using version control system, maybe the project is a monolithic application, maybe the project is not using pipelines, it's not using automation. So with this, definitely, is that we were to start from an existing project in order to apply all of this principle. In contrast, with a greenfield project, you are going to start from scratch. Such as, hey, we don't have nothing. It's up to you how to design all of the code, how to design all of the process. And when we see this from this perspective, it might sound that it's going to be easier, but that's not always true. So greenfield projects appears to be an easier starting point, but that's not always true. Let me tell you when a brownfield project is going to be very practical working with a brownfield project when we want to apply a mindset. When we found a project that contains a very good documentation, that has all the comments that the developers followed, solid principles, all right, solid patterns. When we're not having commented code or when we don't have bugs in the code. So when we have this kind of projects passing from these well-documented projects to a DevOps mindset, it is a good idea. Definitely, this shouldn't be a problem at all, right? So, but definitely spending time maintaining existing brownfield applications limits the availability to work on new code. But sometimes it is a good idea to refactor or just make small changes. And very, very important to notice here that there is a common misconception that DevOps suits greenfield projects better than brownfield projects, but this is not the case. It is not always true. Okay? So let's continue talking about the different systems that exist within the DevOps. Normally, when you're working with assistants, you will have systems that lets you interact with your users, such as if the user clicks there, if the user navigate to this web page, if the user went to that product, something like that. So this is something known as the system of engagement. Basically, we are measuring how the users are interacting with our own applications, and this allows us to prioritize which modules or which features we are going to be working on. In contrast, we have the systems of records, where we definitely, where we are going to monitor how the infrastructure is working. Such as, I don't know, maybe the CPU goes greater than the 80% and I didn't scale that virtual machine, or maybe we're having a very low threshold and all of the virtual machines are getting scaled, but just a small peak of traffic. So there are different systems that we have to consider when we are working with a DevOps mindset. What else? When we are talking about distributed applications such as I have an application that is going to have servers, let's say in Asia, other servers in Latin America, other services in North America, and other services in Europe. Normally, when you add a new feature, there are different strategies, but let's start from the point that you don't want to expose this new feature to all of your users, all right? I don't know, maybe you want to test a subpopulation of your users, how we can achieve this. So we are going to cover this from the design perspective, but also I'm going to mention from the infrastructure perspective, all right? So let's start talking about the different strategies that allow me to test features. For example, first we need to identify the targets, the users that are going to start interacting with these new features. Normally, you will have canaries, so voluntarily test leading edge features such as You have identified a customer that definitely wants to test that feature. What else? Early adopters, people that are going to adopt that instantaneously. So at the moment that we have to release that new feature, that people is immediately start interacting with that specific feature. Users at the end, when you expose that new feature to all of their customers. Okay, so this is from the design perspective. Now, if we want to apply this in a real project application, let's say that, again, let's come back to the example that we have a distributed application in Latin America, in North America, in Europe, and you want to test it just with people from, let's say, from North America. You want to see how this new feature, this great new feature that you was added, you want to see how the people is going to react. As I mentioned to you, you don't want to expose it directly to all of your population. So how we can achieve, or how we are going to be able to just expose to that specific people? By using infrastructure tools such as Azure Traffic Manager. With Azure Traffic Manager, you will be able to redirect the traffic based on the geographic area the user is having. And you may be wondering, okay, but what if the user is having a VPN? Well, in that case, maybe it's not going to be enough, but this is a good starting point to expose just a specific features to a specific population that we decide. With this, we are going to be able to see or to identify how the users are reacting to the new features in order to decide if there is other feature or a sub feature that we have to integrate before exposing this module to all of our users. Other thing is that, as I mentioned before, you should identify the key performance indicators, such as the time that is taking me to deploy an application, the deployment frequency, the deployment speed, the deployment size. For example, the deployment frequency, it is very important to mention that not all the performance indicators are going to make sense. For example, if you identify such as, hey, I want to have a deployment frequency each hour, each 5 minutes. Hey, come on, if you are working on a big project, does it make sense to deploy your application every 5 minutes? Maybe every 24 hours, every 12 hours. At the end, it's going to depend in your specific project. What else? Efficiency. Server to admin ratio, staff member to customer ratio, how many bugs we're receiving at the end of the sprint or at the end of each specific period, how many users are interacting within our applications, or how the infrastructure is reacting to the loads that we are, to the traffic that we are having on that infrastructure. What else? Quality and security, the deployment failure rates, the availability my application is having, if we are detecting a downtime throughout the sprint, throughout at the end of each period in my applications. And the culture, employee morale, and rotation rates. Remember, we want to speed the process, so we want to have developers working on those specific features, but we should identify the rotation rates these employees are going to have. Very important to note here, goals must be specific, measurable, and a time bound. So we definitely need to specify a time bound, such as, I don't know, every 5 minutes, every hour. That will let you make a better decision. Okay, so let me summarize what we already covered on this 34 minutes, guys. We started talking that DevOps is just a technique that allows us to speed up the process while delivering software. These techniques involve continuous integration, such as I have a change in the code and I will trigger a process. Once that process has finished, then I will continue with the continuous delivery, such as I want to deploy that process. What else? I want to have version control systems that allow me to have multiple versions of the code. Then I can also integrate Agile lean methodologies that allow me to identify the different activities my team is working on. Once the application has been delivered, I want to monitor that. What else? You should consider working with cloud vendors in order to scale your applications, in order to just consume what you need. Other thing is to consider having infrastructure as code to automate the creation of your environment, such as Terraform, uh, our templates, among others, and having microservices applications. So it makes easier update a specific feature. One of the one of the most common options to work with a microservices architecture is to work with containers. All right. So now let's continue talking about the different teams that are going to be identified. So in the waterfall approach, so normally it's the traditional way. So you define, analyze, build, and test, and deliver. As I mentioned to you, so you will create a large volumes of requirements, and only when you are done with this document, let's say, you're going to start coding. Which does it make sense? Well, at the end, it's going to depend on your organization, on your project, but normally this kind of approach is not going to be so flexible with the changes. So what else? You already spent time working on the requirements, and just when after 1 month or after 2 months working on a specific feature, the customer realized that he didn't that the customer didn't detect a specific change or a specific feature. Come on, working on those changes is not going to be flexible if we compare with the agile approach. With agile approach is going to be focused on iteration and shorter term outcomes. With this, we will be more flexible when there is a change, and definitely we can adapt in the next sprint. Remember that a sprint is going to last between 2 or 3 weeks normally, and we will be more flexible working on those specific changes. Actually, Agile is a methodology that, but inside the Agile methodologies, we are going to have a group of families, a group of frameworks, such as Scrum, Kanban, Scrum, Kanban, among others. To be honest, I don't remember the other frameworks at this moment. But Agile is going to have 12 principles. All right, let's take a quick look to these 12 principles. Satisfy the customer, welcome changing requirements, delivering working software frequently, work together, build projects around motivated individuals, use face-to-face conversion, measure progress through working software. Agile processes promote sustainable development, continuous attention to technical excellence and good design, simplicity, use self-organizing teams, and reflect on how to become more effective. There are 12 principles in the Agile Manifesto. It's hard to start applying all of these principles. Normally, the recommendations are pick up 3 principles from this list. I don't know, the 3 principles that you like the most. And based on those 3 principles, start applying to your organization right now. All right? So I don't know, maybe you want to start working on self-organizing teams and delivers working software frequently and measurable progress. So just focus on those specific 3 principles, and from time to time, you can add more principles to working within your application. Right? Remember, it's hard to apply the 12 principles as a in a single punch. Just start step by step. Okay. So normally when this kind of projects, other paradigm or other way to work that with a DevOps mindset want to change is the structure of your teams. In the traditional way, we have, let's say, a UA department, services department, and a data and department. All right. So we have personal. Let's say, let's say that you're working on an email application, a voice application, and the TV application. So, all these people is having the same channel for communication. But let's say that you are working with the application A. All right. So when you are designing that application is going to be part of the UI department. Once the application has been designed, then that will be passed to the services team. All right. And just the communication is going to be between these specific members. Okay. So once the services team has done, then it will be passed to the data team. So what is the disadvantage of having this organization, guys? So what is going to happen if suddenly at this stage we are realizing that there is a design that is not meeting the requirements of the customer? In that case, we are going to regret, or we are going to pass that application to this specific department. So horizontal teams structures divide teams according to the software architecture. So we want to pass from having this to have a vertical team. Okay, so in the vertical team, so we are going to have multidisciplinary members, or at the end, we will have communication between all of the members. And with this, we are going to be more flexible when reacting to changes. So vertical teams span the architecture and are aligned with product outcomes, and scaling can occur by adding teams. Of course, this is going to impact in the methodology, in the framework that we are using. This is going to be more related, let's say, if we follow a Scrum framework. The Scrum framework is a framework that applies the Agile methodologies and identifies different roles in our projects, such as a product owner, product manager, Scrum Master, the development team. And with this, it's going to be easier to apply the following teams architecture. So that's why we start talking about the ideal DevOps team. So the ideals, normally some teams hire external agile coaches or mentors that help us identify the different activities, the different roles, plan or sprints. What else? Agile coaches have teaching and mentoring skills, and agile coaches tend to be more both trainers and consultants, and some coaches are technical experts. I mean, it doesn't have to be a technical expert, but it is recommended, of course. And some coaches are focused on agile processes, as I mentioned. So how to define the different activities, how to prioritize the different tasks that has to be delivered, and the frequency, how to create or how to monitor the time each member is spending on the different activities that we're having. And team members must learn as they work and acquire skills from each other. Remember, the communication. Normally in the Scrum framework, we used to have meetings each day that are not going to last more than 10 minutes, where we are going to communicate what we are working on our daily activities. So with this, we can have a cross-team collaboration. So there are different tools such as Slack, Teams, Asana, Glib, Jira. Actually, Azure Boards is also one of the different tools that are part of the DevOps, that allow us to apply the DevOps journey. What else? Cultural changes, more open workspaces, meeting etiquette, outsourcing or better communication, and cross-functional teams, diversity of opinion, rewarding collective behavior. Remember, so we want to have a multidisciplinary team that allows us to achieve those specific goals. What else? Once we have identified the different members, the different needs, so in a later modules, we are going to start talking about the tools that are provided by Azure that allow me to integrate all of this, right? So tools can often enhance the outcomes achieved. Physical tools such as whiteboards, index cards, sticky notes, or project management tools such as Kanban for boards for planning, monitoring, and visualizations. What else? So if you're working with a test team that is going to test your application in order to identify a bug or an error, something that is not completed. So we can have tools that allow us to record how the tester is interacting with our application, or we can record integrate working with our application in order to see how to navigate or how to interact with that specific application. All right. So at this moment, let's continue with the different tools that are available. So what is Azure DevOps? So in the previous minutes, we start talking that DevOps is a set of techniques that allow us to speed up the process, and we can have version control systems, pipelines. Uh, we can plan our project by using different sprints, or we can have different techniques. So Azure DevOps is a portal that is going to offer me different products to apply all of this we already talked before. For example, Azure Boards allows me to have an agile planning, allows me to have a work items or a list of activities that must be completed, and this automate or makes easier the process of creating the reports, such as the amount of time that is taking me to pass from to do to in progress, or the amount of time that is taking me from passing from in progress to done. And of course, all of the members that are involved in that specific project can visualize the different activities that should be completed within Azure Boards. What else? Azure Pipelines. So Azure Pipelines will allow me to automate the process of the continuous integration and the continuous delivery. Of course, each of these guys is going to have its own module. We are saying this from a big perspective. Azure Repos, a service that allows me to have my private Git repositories. What else? We also have Azure Artifacts that allow me to store my own libraries, that allow me to store my own artifacts. Normally, we're going to see this from a library perspective. Now, for example, when you are working with, let's say, Python, there is a common library, a common hub of library that is known as pip. What else? We also have in C#, we have NuGet. In Java, we have Maven. So normally when you don't want to expose, let's say that you create your custom library, you don't want to expose it, you don't want to make it public, or you are just working with an internal library that can be consumed by just the members of your teams. In that case, if you want to make sure that this library is going to be consumed just by the members of your team, Azure Artifact is a service that allows me to centralize these libraries in order to share it just with the people that I mentioned. But this is not a repo, guys. Very important to mention. Azure Artifact is not a repo. It's just a service that allows me to upload my own libraries. And each library is going to have multiple versions. What else? Other service that allow me to test and track all the activities that was completed, automatically create bugs, and so on. All of this, guys, is part of the Azure DevOps portal. Actually, I would like to show you a quick tour to the portal, guys. If I type in my browser, give me a second, guys, while I'm opening. If I type here Azure DevOps, let me scroll down. So I can start free. I need to specify my account. So the first thing that you need to create inside the Azure DevOps, of course, is your account. Once you create your account, you need to create an organization, all right? So in the organization is going to have a name, and that's it. Just the organization. In this case, I have 1, 2, 3, 4, 5 organizations under this account. Inside each organization, you will have projects, all right? So each project, guys, is going to provide to you under this portal the different tools that I mentioned before. So here we have the Azure Boards, where we can create, let's say, work items. Actually, let me go back. Let me select another project where we are having a more, I think this one. Let's say, okay, so here you can have the different activities that can be completed. You can have the backlogs, you can have the boards, or you can have a column that allow you to pass. Let's say that here we are having a new item. Then the other stage that we have is design or doing. So we can pass from one activity to other. And this allows me to automate the documentation or the process of creating the documents. What else? In the overview, we can also create wikis. Wikis allow us to share communication with all the members, such as I was working on this specific artifact and identify or this documentation for this specific file, for this specific, this is how this pipeline is working. What else? We also have the repos. So instead of using, let's say, GitHub, you can also use Azure Repos. And there, here, you can control which members are going to have access to those specific repos, as well as have commits, as well as have pushes, branches. What else? You can also have the pipelines. So in this case, you will have the continuous integration pipeline that can be designed. Let me edit this with a YAML configuration or with a classic editor, which will allow us to have a graphical user interface. Remember, so these pipelines can be designed with a graphical user interface or by having a YAML implementation. Let me show you how a YAML implementation looks like. I must have this in one of the projects. So let me go here, configuring pipelines as code with a YAML. Again, if I go to pipelines, I can choose this pipeline and click here on edit. And this is how a pipeline looks like in a YAML editor. All of the process, for example, here, if this pipeline is going to be triggered every time a change is detected in the main branch. We will have multiple stages that we are going to deep dive more into details in a later module. But again, this process can design or can be can be configured in a YAML file. What else? We can also have the releases. Once the pipeline has been, once the continuous integration part has been completed, what I'm going to do with that product that was created. Actually here, let me show you that we can have multiple stages, as I mentioned before. Maybe you will have one stage that will let you test, and once you have tested your application, you can pass to the different stage. All right, so this is part of the releases pipelines. What else? We can have test plans. So a service that allow me to track when we are interacting with our application in order to list the bugs that were detected, in order to see if a feature is working as we expected, and so on. And then we have the artifacts, as I mentioned before, a service that allowed me to store my private libraries, right? So instead of using a public repo such as pip, such as Maven, such as Node in JavaScript, I can use Azure artifacts. So all of this is part of the Azure DevOps portal. Remember that you need to create an account, and inside your account, you will create your organization. And inside your organization, you can create your projects. Each project will offer to you the different tools that are listed inside this specific slide. What else? Other service that is provided by Microsoft. We have GitHub. We can also execute pipelines in GitHub. This is something known as GitHub Actions. So, but here we will have code spaces. So this will provide a cloud-hosted collaborative development environments. We have the repos. So this is how GitHub started. So provide cloud-hosted and on-premises Git repos for both public and private projects. We have actions that allow me to create workflows or pipelines with environment variables and customized scripts. Packages that allow me to store my private or public packages. And security Well, we will continue talking about security in a later module, but essentially is that when we have a pipeline, so well, the term security when we're working with DevOps will have a broad approaches. For example, maybe you have a database and you don't want to expose the password in your code, so this you can integrate Azure Keyboard Service. Other perspective security could have is that when you are pushing or when you are using a public library, maybe that library already contains some vulnerabilities. So we need to define a mechanism that allow me to identify vulnerabilities in the code that we are introducing, or vulnerabilities in the code that is introduced by using a third-party package, so an open source library. So again, so we need to automate, or we want to integrate this within our automate process. What else? We can also identify which users are going to have access to those specific projects or to those specific libraries. All right, such as for non-Microsoft tools like Git, NuGet, or Xcode, you can use personal access tokens. Azure DevOps is pre-configured with default security groups and permissions. And you can also configure app access policies and conditional access policies. So how this is going to imply this? So within our DevOps organization, guys, normally we want to give access to other entities. So for that, we need to create something known as personal access tokens. With the personal access tokens, we will be able to specify the different permissions the entity that poses this token is going to have. Such as here, let me show you the different scopes. Agent pools is something that we are going to talk in a later module. Analytics, auditing, build, code, connected server, deployment groups, environments. So with this, we can create a personal access token with an expiration date. All right. So this is going to be very useful when we are working with multiple members or with other entities that are going to have access to the different services that we have within Azure DevOps. All right. What else? It can also, Azure DevOps can also be integrated with other tools, such as Trello integration tooling is a free, flexible, and visual ways to organize anything with anyone. Then we have Solidify, offers a tool for Jira to Azure DevOps migration. And while third-party organizations offer commercial tooling to assist with migrating other work management tools like AHA, Azilla, and ClearWest. What else? Let's continue talking about migration tools. So we can also, Azure test plans are used to track sprints and milestones. There is a test and feedback extension available in the Visual Studio Marketplace. We also have Apache JMeter. It's an open source software written in Java and designed to load test functional behavior and measure performance. Tester, a tool that can be used to automate the testing of PowerShell code. SAP UI provides another testing framework for SOAP and REST testing. So there, if you're using Microsoft Test Manager, you should plan to migrate to Azure Test Plans. So at the end, we are just saying the different techniques that allow us to speed up this specific process. Now, let's deep dive more in details with the Azure Boards, right? So one of the techniques that are part of the DevOps mindset is that we want to, give me a second, guys, while I'm taking some coffee. Okay, thank you so much. Well, as I mentioned, so we want to monitor the different activities that our teams are going to be working with. So what are the different tools? So we have GitHub project boards. Project boards are made up of issues, pull requests, and notes categorized as cards that you can drag and drop into your chosen columns. Or GitHub Project Beta are a new customizable and flexible tool version of projects for planning and tracking work on GitHub. So this is provided by GitHub. Within Azure DevOps, we also have the Azure Boards. So with this, I will be able to create different items. Now, one thing that is very important to mention, guys, is that when you are creating your project within your organization, you need to identify the type of work item process that you are going to have. Take a look at this, guys. I will create a basic project. So the different type of work item process that exists here is Agile, Basic, CMMI, or a Scrum. In this case, let me choose the Basic, and the name will be Basic Project. Let's wait for this project to be created. And while this project is being created, I will open another tab and I will create another project. In this case, it will be a Scrum project. Scrum project. So I have created two projects, guys. In this case, I have the basic project, and in a few moments, I will have the Scrum project. Remember, this was created when I was, this was defined when the project was being created. So how this is going to impact? Hey, Daniel, we're talking about boards, all right? Let me go here to the work items and take a look at this. In the work items of the basic project, I only have epic, issue, and task. These are the only three work items that are available under the basic project. If we go to the Scrum project, let's take a look at this. We have bug, epic, feature, impediment, product backlog item, task, or test case. All right. So based on the type of project that you select, the different work items that are going to be available. All right. Among other features, such as, let me go here again. The project name, the description, the visibility, the type of version control that you're going to be working with, as well as a work item process. When a project is being created, remember that a project is going to be part of an organization. All right, so once we have this, then we will be able to work with the Azure Boards. With this, we can have different columns, as I showed you before, that allow us to pass from one activity to another. Let me see, where do we have this? I think that on this project, if I go to boards, I already have a list of work items. So if I go to the backlogs, I mean the different items that must be working with. If I select any activity, I will be able to pass from one state to another. In this case, I only have the new, approved, submitted, done, remove. I can also assign this to the different members that are part of my team. I can also add comments. I can also add links. All right. So with this, I will be able to track all the activities that should be done. What else? I have the boards. With this, I will be able to pass from one state to another, or to done. Or I can also modify this, for example, in the case that I want to assign this to a specific member. I can also perform queries, guys. So with this, for example, I can create a query that allows me to filter all the current bugs, right, specific for a given date, or all the items that was assigned to a specific member. So with the queries. And actually, having these queries are going to be very useful when we're talking about the release gates. We will discuss this later in a later module, but remember that we can create queries that allow us to filter the different work items that exist in my project. What else? We can also link this to, we can also link GitHub to Azure Boards. Actually, we can also link it with other tools such as Microsoft Teams or such as Slack. And the main idea is that we can install an additional extension, in this case, for example, with GitHub, and automatically we can create a link that take me directly to that specific branch, directly to that specific folder. In the case of Microsoft Teams, we can also create a comment that automatically redirect me to that specific project. Let me show you. Let me open the Microsoft Teams application to just show you a quick demo here. Give me a second. So take a look at this, guys. So this is my desktop application. I can create a theme here. Let me provide a name, create from scratch, private, testing, boards. Actually, I already have it. I didn't mention before. I already have another theme here. Let me use this one. And automatically, when I type in here, new conversation, I can apply, hey, we need to fix this, I don't know. And automatically, there are some extensions. Well, not automatically, sorry. We can install additional extensions to Microsoft Teams that allow me to see, for example, Azure Boards. With this, if we integrate with an existing project, automatically, I can list a board that exists, and automatically this will create a link that is going to take me to that specific project. Of course, with this, there is a delay between. Actually, let me show you that if I open or copy link, I will open Azure Boards. Okay, so I don't have access, but in another browser, this was open. There we go. What else? We can also configure our GitHub projects. So we can use a board template to create a project board with automation already configured. You can also copy a project board to reuse its customization for similar projects. So basically, we can configure all of the projects and measure or have or visualize all the iterations that has to be completed within our projects. What else? We can also have discussion between all of the members. So we can have, as I mentioned before, we can have wikis, or we can send comments across all of the members. That's it, guys. So the different tools that are available that allow me to adopt let me start with the DevOps mindset. Now, what else? Other thing, as I mentioned, is that we have source control systems. So when it was introduced, DevOps was a revolutionary way to release software quickly and efficiently while maintaining a high level of security. Source control, version control, is a critical part of DevOps because actually almost all the pipelines are going to be triggered by something by an event that occurs in the version control systems. So actually, the foundational practices we have, or in the foundational practices of DevOps, we have different stages. And if we compare the defining practices and associated practices against the practices that contribute to success, we are going to see that version control systems is in both columns. I mean, in practices that contribute to success. So basically, we want to have a system that allow me to track the multiple versions my files are having. Files, not only code. Okay? And why I'm saying this, that not only code, because we can have different types of files. We can have a Docker file, or we can have a YAML definition. Remember that my entire Python can be defined with a YAML definition. And that if we have multiple versions of this specific project, like why don't we store it in a YAML file that can be part of a version control systems, and this let me have multiple versions of that specific process. So a source control system allows developers to collaborate on code and track changes, use version control to save your work and coordinate code changes across your team. So save a snapshot of your file so we can have an entire history with multiple versions these files are having. And source control protects source code from catastrophe and the casual degradation of human error and unintended consequences. Okay, so what if we introduce an error by mistake? Very easy. There's a command within Git, for example. It's just Git checkout that allow me to recover a previous version. So what is the process here? If we again visualize an entire Python, how a Python is going to look like. So we have a version control system that every time a change is provided, this will trigger a process. That process, maybe we are going to build something such as we will build, let's say, a Docker image, we will compile an application. Then once this has completed, then we're going to perform all of the unit tests. We can define or we can provide a strategy that allow me to identify if an amount of unit tests didn't pass, I'm not going to deploy that application. So we can have multiple criteria across all of these stages. Then I can deploy my application, I can test it, or I can start integrating or interacting within that application from a testing environment. And once this has passed, then I can move to the production environment. All of this, guys, will provide us with some feedback that can be provided by our customers, by our own developers. But at the end of the day, so we want to speed up the process, and we want to guarantee, or we want to make sure that we are also provided with a good quality code. So actually, based on this, what are the best practices when we're working with source control systems? Make small changes. So do not wait until the entire feature is completed to make the commit. Or don't commit personal files. It's not a good practice. Be careful on what you push to your repos. Update often and right before pushing to avoid merge conflicts. It is very common that a lot of people is working on different features. So it is a good practice to pull the code first, to make sure that you are having the most updated version, and only then merge what you are working with. At the end, these are different practices that are going to apply on your organization or not. But that's it, guys. Remember that we want to avoid having merge conflicts. What else? Verify your code changes before pushing it. So you have to make sure that the code that you are introducing compiles and all the tests are passing. Pay close attention to commit messages, as this will tell you why a change was made. So when we are working with the version control systems, every time a change is made, we need to provide a message. There is a bad practice that I have seen a lot of teams that they don't put an entire message, such as change was made, bug was fixed. Okay, which bug was fixed? Or which feature was introduced? So every time you made a change in your repository, it is a good idea to provide a message that allows us to identify what is the difference with the previous version. Or link code changes to work items. It is another good practice. No matter your background or preferences, be a team player and follow agreed conventions and workflows. Actually, there are two types of source control systems. We have centralized control systems and distributed source control systems. Centralized is when you have a server, and all of your members are pushing the changes to that specific service. Example of this are Team Foundation Version Control Systems, Subversion or SVN. And what is the one of the most important characteristics of this type of systems is that there is a single central copy of your project, and programmers commit their changes to this central copy, and that's it. So you are not having any well, you are just going to have the production or the most common version to your own computer, and all of the code are going to exist in a single server, just a single version. All right. Then what are the strengths? Easily scaled for very large code bases, granular permission control, permits monitoring of usage, and allows exclusive file locking, such as, hey, if I don't want to, a user makes a change within this specific file, I can lock it. It is best used for large integrated code bases, hard to merge file types, or audit and access control down to the file level. So, what is the difference with a distributed source control? In a distributed, so each developer will be able to clone a copy of the repository. And by cloning the repository, each developer is going to have access to all of the versions this project has already have. Such as, I don't know, maybe that developer wants to see a feature that exists 2 months ago. Why? I don't know, but it is possible when having a distributed source control system. And what is an example of this? Mercurial, Git, Azure. So the strengths are cross-platform support, an open source friendly code review, model via pull request or double history, and best used for a smaller size and modular code bases for highly distributed teams. That doesn't mean that we don't have a server. We can have different services such as Azure Repos, GitHub that allow us to centralize. That that doesn't mean that I am using a centralized source control system. It is distributed in Git. The main idea here is that I will be able to download the multiple versions my project already has. So remember that Git is a distributed source control systems, and Team Foundation is a centralized source control system. Right? So in Team Foundation version control system, the team members have only one version of each file on their developer machines. And with Git, each member is going to have all of the versions my project already has. What else? Well, when we're working with Git, we can have different branches that allow me to have multiple features. So with this, each developer is going to be working on each feature, and only when that feature has tested, we will be able to integrate that new feature with our main branch. Normally, you don't want to change the main branch, or you don't want to code under the main branch. Normally, the main branch um, is going to be listening for new changes. Okay, it is a good practice. What else? A pull request. So every time a feature wants to be added, we create a pull request, and that request should be accepted or must be accepted for the person that is in charge of the main branch or on the main repo. So with this, we can have multiple versions within our code. But what is the service provided by Microsoft or by Azure DevOps? So with Azure Repos, we can have a set of version controls to manage, for example, our code. In that case, it is very important that when you are creating your project, you need to specify the type of version control that you are going to have, right? So for example, and you can specify Git or Team Foundation version control system. Actually, the recommendation is that if you don't know, start working with Git. Normally, Team Foundation version control system is for existing projects, for existing repositories, and you want to integrate within Azure Repos. Actually, there is a tool that allows to migrate from Team Foundation to Git, and it's provided by Azure DevOps. GitHub is another service. It's the largest open source community that again allows us to having our codes, having multiple versions of the code in the cloud. Um, what else? I can also manage the teams. I can also manage variables. I can also create pipelines there or give something known as GitHub Actions or workflows. And that's it. So these are the different version control systems that are available. So if you want to migrate from Team Foundation version control to Git, there is a tool that allows me to import, let's say, just the production branch or full synchronization. So it is very important to mention that we can migrate up to 180 days. Or only the latest version of the code will be migrated. History remains on the old server, or we can we can also migrate with the history. Remember that every commit we made, we can provide a message. We're almost done with this module, guys. Let's talk a little bit about GitHub Code Spaces. It's a cloud-based development environment hosted by GitHub and avoids issues with old hardware, software, highly portable. It's based on Visual Studio Code, work from PCs, tablets, Chromebooks, connect to code spaces from Visual Studio Code, and protect against proliferation of intellectual property. This is a service provided by GitHub. Now, what are you going to do in the labs, guys? So there's other session that is going to be in 1 hour, almost 1 hour, when you are going to be working in your labs. However, I would like to give you a quick overview how these labs are going to be consumed. So normally in the event instructions, you will see the instructions on how to complete these labs, but basically you are going to have an organization, and inside the organization you will clone projects. Let's say, let me give you an example of this. We want to work with the Azure Boards. So with this, I need to have multiple activities. I need to have different work items that exist. You might be wondering, hey, Daniel, do I need to create these work items from scratch, one by one? The answer is no. Because in your labs, you are going to interact a lot with something known as Azure DevOps Demo Generator. So with the Azure DevOps Demo Generator, automatically, let me open it. This is another service that as long as I provide my account, I can choose a template. In this case, there are multiple templates out there. Okay, so there are multiple templates. For example, if I want to integrate Terraform, Azure Machine Learning, Key Vault Service, Docker, Kubernetes. So when I am using this template and I provide a project name, and then when I provide an organization, automatically it will create a project within my organization, and that project will already contain some base. A base such as it will already contain some work items to work with. It will already have some pipelines already defined. And the main idea is to follow the instructions, because maybe in the first lab, you are going to be working with your boards. In order to pass from one activity to another. Or what else? You can also create a new item, such as my new item, and you can assign this activity to a specific member, or you're going to pass from active to resolve, and you're going to see how to manage this in more detail. This is something that you're going to do in your first labs. What else is going to be done in your first labs? Working with Git, such as you can have a local computer and you can connect to a remote repository by cloning directly from this option, and you can push the changes from your local computer. And once you push your changes to your local computer, you will be able to see inside the commits that exists within Azure repositories. That's something that you're going to do in your laptop. However, I just wanted to give you a quick introduction on what are you going to expect from your labs. Remember that if you have any question, there is a team here from the support that is answering to all of your questions within the chat. All right, so let's continue with our last module for today, guys. Give me a second while I'm opening my presentation. The development for enterprise DevOps. What you should consider when you are working with this kind of projects. So if we focus this in Git repositories, normally, as I mentioned, as I showed you before, you have a project, and each project will have multiple repositories. Actually, this is going to impact in the monorepo versus multi-repo. Monorepo essentially is that all of the source code is kept in a single repository. You can see this is not strict, but this can be seen as a monolithic application. Or why don't have multiple repositories where each repository is going to trigger its own pipeline? Or actually, each repository could be the code of a microservice. Right? Okay, so a repository is a place where the history of your work is stored. Azure DevOps projects can contain multiple repositories. The fundamental difference between the monorepo and multi-repo philosophy boils down to a difference about what will allow teams working together on a system to go fastest. What else is that we can have, it is a good practice to have different branches. And with this, we can specify different strategies. The most traditional, one of the most common traditional approaches is to have a branch per module or have a branch per feature. And the developers are going to be working within that specific branch. And just when that feature is completed, then we can merge it. This is something known as feature branching, where all feature development should take place in a dedicated branch instead of the main branch. The forking workflow, every developer uses a server-side repository. With this, I will be able to separate working on different branches and with different members. So again, what is the process here? Create a new branch, then the developers are going to be working on its own branch. They are going to be adding more code, and they will add more comments. Once these changes has been made, they can perform a pull request. Remember that pull request is going to impact in the owner of that repository, and just when the owner accepts the pull request, then that code is going to be merged with the main repository. We can start discussing the code, or before accepting the pull request, we can review the code, and only then we will be able to deploy it and merge it. What else? As I mentioned, so GitHub Flow is a lightweight branch-based workflow where we are working with different branches, and just when that change is completed, we can merge it with our main branch. So forking workflow gives every developer their own server-side repository. Each contributor has not one but two Git repositories, a private local one and a public server-side one, most often seen in public open source projects, and contributions can be integrated without the need for everybody to push to a single central repository. So let's start talking about a pull request. It is not the same, guys. I already mentioned the pull request sometimes before, but it is very important to identify what are the differences between merging and having a pull request. So take a look. I will open GitHub here. Type github.com. Actually, let me see if I can access to my. So actually, these are. Well, I don't have multiple public repositories, but take a look at this. This is this repo. I have two options here. I can clone it, and this, I mean, by cloning this repository, I will download this entire repo to my local computer. And if I made a change within that repository, I won't be able to push it because I am not the owner, right? So I just create a copy of this repository on my local computer, but I'm not able to change the remote repository. So how can I do this, guys? There's other option known as fork. By forking this repository, it will create an entire copy of this repository in my own GitHub account, right? In my own GitHub account, I will have a copy of this entire repository. That is the forking, that's what the forks does. And with this, once I have that repository in my own GitHub account, then I will be able to clone it. I will be able to make some changes. And since I am the owner, actually, let me draw this. Let's create a diagram here. So remember, so here I have Liz Daniel account, then another developer account. And with this, we have this repository. All right, so if I clone it, remember, if I clone it to my home computer, I will be able to make some changes here that I will be able to push it. I'm not allowed because I'm not the owner. However, if I fork this repository, what this is going to do is to create a copy under my account, and then that copy I will be able to clone it. I will be able to clone it. I will be able to make some changes, and I will be able to push it because I'm the owner. Okay? However, what if I want to notify to Luis Daniel that I made a change that could benefit its own repository? This is where the pull request comes into play. Pull request. So with it, I'm sorry guys, I have a typo here. Let me provide just this for the pull. So with this, I will notify the owner that there is a change, and we are waiting to be accepted. So the pull request lets you tell others about changes, makes you have collaboration using the shared repository model, review and merge your code in a single collaborative process, and be sure to provide good feedback and protect branches with policies. What else? We also have a mobile application that allows us to have the approvals. So the application can render markdown files, images, PDF files, or we can also add comments. What else? Other service that is part of GitHub. We have Gitbooks. So GitHub is a mechanism that allows arbitrary code to be run before or after certain Git lifecycle event. Of course, let's say that you already test your code, and before deploying, you want to, I don't know, query something within your code. You want to perform an operation. So then once this criteria has passed, then you will deploy. And once you deploy, another criteria is going to be executed. So with this, we can enforce policies. We are going to ensure consistency and control your environment. So with this, I will be able to identify if this is going to impact other code or introduce code quality issues, drop the code coverage. For example, there can be processes that are going to be executed in the middle, such as a static analyzer, a code coverage analyzer, or we can identify if there is a vulnerability introduced by one of the packages that we are using. All of this with different processes that are going to be executed while the pipeline. Now, there are different alternatives, or there are different practices when we are working with version control systems, such as InnerSource or Explore, Foster, InnerSource. So basically is that we are going to have a fork, and with this fork, I will be able to identify other users that, or the owner of the repository, that there is a change that I want to introduce. We recommend the forking workflow for large numbers of casual or occasional committers. InnerSource brings all the benefits of open source software deployment inside your firewall. So basically, it is we are having a forking repository. So instead of having a branch, and instead of making a change on that branch and then merging with our main repository, so we can have multiple repositories, and just when the change was made, then we can proceed to having the pull request. But before, but before we have to be done the forking. Okay, so what is the forking workflow? Create a fork, clone it locally, make your changes locally, then push it to my own repository, and only then forking within the main repositories. Actually, this is going to impact when we're working with large repositories. There are when we're working with files that are going to be very large amount of files. There is other tool known as Git large file storage that allow us to work with this kind of files. So based on the different sizes, based on the different files that you are pushing. All right. What else? There is other tool, guys. There is other issue that we should identify when we're working with this kind of projects. Going back to the base, guys, remember that we want to optimize the process. We want to speed up the process. But while we are trying to introduce modules or features faster, maybe we are going to introduce code that is not of the best quality as possible. That's why it is very important to consider solid principles in order to have a good strategy in our codes. What else? Other thing is that we should identify the code quality. For example, our short deadlines, a lack of coding standards, our poor technical skills can lead to code that is not clear and readable, documented, maintainable, extensible, secure, or efficient. So how we can guarantee this, or at least how to improve the odds that my code is going to be for the best quality? By using solid principles, or by using documentation, by using comments. Actually, there are tools that allow me to identify this. Measure and technical depth. There are other packages that can be integrated within your pipeline that allow you to identify, such as, sorry, someone opens your microphone? Did somebody open your microphone, guys? Okay, let's continue. Well, as I mentioned, there are some packages that can be integrated within your pipeline that allow us to monitor these specific tasks, such as, hey, there was for example, there is a warning on that code, there is other warning, or you should refactor this because there's something known as code smell or technical debt. Or technical debt is the penalty that you are going to have in the future by taking a decision now in order to save time. So if you want to save time right now, but you are going to incur in a bad practice, you will suffer a penalty in the future, and that is something known as technical debt. So as I mentioned, all of these tools can be integrated within your pipeline, or actually within Visual Studio Code. And the pen is a Visual Studio extension that assesses the amount of technical debt that a developer has added during a recent development period, typically in the last hour. And ReSharper code quality analysis is a command line tool. It can be set to automatically fail builds when code quality issues are found. Okay, so actually, what are the different sources and impacts of technical debts? Lack of coding style of standards, lack of poor design of unit test cases, ignoring or not understanding object-oriented design principles. Or actually, I will say solid principles, because in order to apply the solid principles, you should understand the object-oriented design principles. Monolithic classes and code libraries, insufficient comments and documentation, not writing self-documenting code, or taking shortcuts to meet deadlines, leaving that code in place. So all of this, remember, is going to introduce technical debt. Remember that technical debt describes the future penalty that you incur today by making easy or quick choices in software development practices. How we can measure technical debt, guys? By failed deployment percentage, failed build percentage, the ticket volume, the bug bounce percentage, unplanned work percentage, right? So all of these are different indicators that allow us to measure the technical debt. The main idea is that we want to use automated tools, or that we want to use tools that allow us to automate the identification of technical debt. Just add problems during development that makes it more difficult to add customer value, saps productivity and frustrates development teams, makes code both hard to understand and fragile. One way to optimize the accumulation of technical debt is to use automated testing and assessment. And how we can automate this? Within your pipeline. Within your pipeline, there are different tasks, different third-party packages, there are multiple packages that allow me to analyze this kind of problems within our code. This will give me a result, and I can query that result. And if I want to automate that process, I can create a process that allow me to see, such as, hey, if I have this validation, or that this validation didn't test, doesn't make sense to continue deploying that application. If I already know that there is a bug there, if I already know that I'm having poor quality or poor performance, I can decide if I want to continue within a process of my automation or not. All right, so Azure DevOps can be integrated with a wide range of existing tooling that is used for checking code quality during builds. What else? We have, for example, Sonar Cloud. We have White Source Vault. We also have the other packages that we mentioned before, such as NDepend, ReSharper, SonarQube. Okay, so there are multiple tools that allow me to monitor all of this. Okay, so what are we covered on this module, guys? We covered the different version control systems that exist. Then remember that we have centralized and distributed, and you need to define, or you need to specify this at your project level. When you are creating your project, remember that you need to specify the type of work items that you are going to have, the work item process, as well as the version control system. Distributed or centralized. Based on this, each project is going to have all of the features that are available, such as boards, repos. Within the repos, we can have the comments, all the comments that are going to be done. Actually, I can select a comment and I can see, or I can visualize the multiple changes, or the different pushes, the branches that are available. Actually, I can create, let's say, a pull request. What else? I can create a branch here, new branch, that is going to be based on other branches. Actually, you can delete a branch and recover it. You will see this in another lab, such as, hey, you are going to be provided with an entire project. Then you can delete the branch, and then you will see how to recover a deleted branch. So all of this can be done directly within Azure repositories. And remember, very important to remember the fork workflow. So the fork workflow is that create a fork. By forking a project, it will create an entire copy of this in our own account. Then we can clone it locally. And since we're cloning it locally, we can make some changes directly, and those changes can be uploaded. And since we are the owners, we can make those changes. And if we want to integrate this with the original repository, we can create a pull request. That pull request should be accepted from the owner of that specific repository. All right. So remember, guys, that if you have any question, feel free to post it into the chat. We're almost done with today's session. Okay, so actually, let me remind you guys how the labs are going to be done. So in your events instructions, you can have access. Well, inside the events, you can have access to the instructions. But basically, you are going to create an organization, and within your organization, you will create different projects. Normally, by using the Azure DevOps demo generator, you need to specify. A different template, and based on the template that you specify is the project with some previews or with some items are going to be created, such as some work items, some repositories, some pipelines. All of this is going to be provided based on the template that you choose. Which template are you going to select? The template is going to be selected based on the lab that you are working on. All right, so actually, we are already done with the theory, guys. I see some questions here in the chat. So, okay, so for example, I will try to answer to some of the questions that we have since we have time, guys. So what's the difference between technical debt and code smell? Technical debt is just a penalty that you are going to have in the future. That's it. It can be related with code or not. And code smell is code that is not following the good practices. Normally, a code smell is going to take us to a technical debt. But technical debt, there can be multiple sources of technical debt. Code smell is an example of a source of technical debt. Okay, so remember, technical debt is just a future penalty that you're going to have by saving time right now. And code smell is when we're not following good practices and we have commented code, let's say, or we have code that is not working as expected. We have functions that are not being called. This is an example of code smell. All right, so then another question, can you describe the difference between merge and pull requests? I already did it, but let's do this again. So let me visualize this again. So we have the owner. We have owner account, okay? And inside the owner account, we have the repo. Let's imagine that we're working in GitHub. This is the owner account, and this is the repo. I can access to that repository here, and I can clone it. All right, I can copy this entire direction. I can open my terminal and type git clone blah blah and this URL. What this is going to do, this will clone this entire repository to my local machine. And by cloning this, I will be able to make changes in my local machine. But what if I want to make changes with this. I won't be able to do this. This is not possible. This is not possible because I am not the owner. All right? So how can I do, or how can I work on this repository without being the owner? All right, so in order to do this, first, I need to create, um, I need to create a fork. All right, let me write it here, a fork. By forking a repository, I will have my account, all right? And inside this account, I will have a copy of this entire repository. With this, again, I can clone it locally, and by clone it, I can make different changes. So the change between each version and other can be merged, right? So every time I'm making a change in a repo, I can commit those changes. But if I want different branches and I want to integrate both branches, this is something known as the merge. All right, so remember, I have two branches, and these two branches, I want to have similarities. This is something known as the merge. And what's the difference with a pull request? Okay, let's continue with this explanation. With this, let's imagine that I have multiple branches, and each branch, has made some changes, and we already merged something in a single branch. I can update this entire repository, but remember that the goal is to update the owner account. If I want to make a change in the owner account, what I have to do is to create, or is to open something known as a pull request. Actually, the name might confuse, guys. The name should be such as a push request, to be honest. All right? It has to be push request. Because in this case, we're telling to this owner, hey, owner, there is a change that I made and I wanted you to accept it. In that case, the owner will be able to review the code and will accept if we merge our changes with the original repository. These are the differences between the pull request and the merge. All right? So what else? How to access to the lab? As far as I know, guys, you have the instructions in the events where you are going to be able to see all of the instructions. Okay, and in order to access to those labs. In a few moments, we are going to provide more details about this, but that is basically it. Okay, that's it, sorry. Thank you so much, Sergi. So we're almost done, guys. Remember that if you have any question or any inquiry, let me remind you how these labs are going to be completed. You already have your instructions, and based on this, your instructions are going to ask you sometimes go access to the Azure DevOps demo generator. You are going to clone one of these specific templates within your organization. And based on the project or based on the template that you choose, a bunch of items are going to be created within your project. By default, for example, one project will have some work items you will visualize. Other templates are going to have some pipelines already created. In the first projects, in the first labs, you basically are going to play with the items that are provided. Let me go here. You're going to be provided with a bunch, or with a list of work items, and you are going to modify, such as the state. You will modify the discussion. You will modify the priority, the severity. You can add some comments. That is going to be one of the first labs. The second labs is to start working with the repositories, such as you have different branches, and you will be able to connect to your local machine, perform some changes, And those changes are automatically are going to be visualized here, such as if you create a new branch, if you made a new push, if you perform a pull request. So all of the changes are going to be visualized directly from Fadil has see I'm seeing request lab access and I click it. I will receive an email once I have access. Let's wait for the support team to answer this regarding to the lab access. All right. Okay, so maybe we need to wait for, I have another question here from Q&A from John. The question says, is instruction sent to my email? I didn't receive an email yet. Let's wait for a few moments, guys. I have another question from Brad. Can you put the demo generation tool in the chat, or is it going to be supplied in the lab? It will be provided in the lab instructions, Brad. Don't worry about this. Okay, I have another question here from Sami. I have requested for the access in the event portal, but I haven't received any information regarding the same. Let's go from the technical team, guys, from the support team, to see how the labs are going to be accessed. Let's wait for a moment, guys, regarding the lab environments. But basically, remember that you will have the Azure DevOps demo generator where a template will be selected. And based on that template, a project will be created with different activities. Okay, guys, so at this moment, we are done with the theory. In a few moments, you will get more information regarding your labs, guys. All right? So we're almost closed the session. Chris, I have another question from Christopher. You're always talking about GitHub. No, Christoph, I am talking about Git repositories. Git repositories, and actually we can also have repositories within Azure Repos. Okay, so with this, again, we can create our own repositories, or we can fork it, or we can create more files and so on. Actually, if I click here on repositories, I can create my folders and so on, or I can create a new repository and so on. So the process is going to be the same, such as having a Git repositories. Okay, I have another question here. I've submitted the lab request. It says it will take 24 hours to get access. Thank you so much. So I have another question from Satish. Is lab going to charge or it is free? As far as you know, it is completely free, Satish. Okay, so with this, we're done for today's session, guys. Thank you so much. Hope this has been informative for you, and see you tomorrow. Actually, there will be another session in a few hours where you will have technical help to the lab's environment. All right, that session I think that is going to start in almost 30 minutes. Thank you so much, guys, and see you tomorrow.